Hello everyone, welcome in the class of geography. Again, I'm here to deal with the section of oceanography, and as you know that in the previous session I dealt with uh, the section of temperature of ocean water. I started that chapter, but in that chapter, in that session, we have left with one of the major section, and that is the distribution of temperature in the ocean water, right? So in this session I am going to discuss with that section. Okay, see here, when we talk about the distribution of temperature in the ocean water, before that I told you that actually the distribution of ocean water takes place in two manners. One is a vertical distribution of temperature, another is the horizontal distribution of temperature. Vertical distribution of temperature means the distribution of temperature is going to be happen from the sea surface up to its bottom. And when we say that it is horizontal distribution of temperature, so here we will see the distribution of temperature from the equator towards the poles. That means in reference to the latitudes we will see. So one by one I am going to discuss with you these two sections, vertical distribution and horizontal distribution. First of all, I would like to discuss here the vertical distribution. But before that, here one thing which you can see here on the board, and that is written as temperature depth profile. So as I was telling that I am going to discuss the vertical distribution of temperature. When we see this vertical distribution of temperature, that means from the sea surface up to its bottom, from the sea surface up to its bottom. So you can see and you can observe a proper gradation of the ocean water in terms of temperature, in terms of distribution of temperature, right? And that distribution is also known as the temperature depth profile, right? It is also known as the temperature depth profile, right? So what is written here? The temperature depth profile for the ocean water shows that how temperature decreases with the increasing depth. What does it mean? It means that when we talk about the sources of temperature, the source for the temperature of the ocean water, the basic source is the sun. Solar radiation, when falls on the surface of the ocean water or the surface of the sea water, it gets the heat energy, and by that heat energy the temperature of the sea water is decided. It is very obvious that when we see the incidence of solar radiation from the equator towards the poles, so the maximum amount of heat from the incident solar radiation is received on the sea surface in the latitudinal region, which is lower latitudinal region. In the lower latitudinal region, maximum amount of insolation is received, and as we go from the equator towards the poles, the amount of solar radiation, the amount of incident radiation get decreased. And so that when the amount of incident solar radiation get decreased towards the poles, the amount of heat energy also get decreased towards the poles. That means very clear that actually when we go from the equator towards the poles, the temperature also get decreased. Very clear. But here we have to discuss about the vertical distribution. So for the vertical distribution, here you have to understand that actually when we see the maximum amount of heat energy received by the ocean water, so it is received at the sea surface, at the ocean surface, and from the surface the distribution of temperature is taking place. Distribution of temperature is taking place according to the transmission of heat downward. The heat get transmitted downward, and when we talk about this transmission of heat towards the bottom of the ocean, it takes place with a particular process. That particular process is called as convection. I told you earlier that for the gases and water or liquid, you can say the transmission of heat is taking place with the process of convection. It takes place with the process of convection. Okay. Now, the maximum amount of heat is received at the surface. The transmission is taking place. So, as the transmission is taking place downward, obviously the amount of heat energy gradually decreases towards the bottom. And so that the temperature also get decreased. That is what it is written here. That the temperature decreases with the increasing depth. Obviously it is so. Because the amount of heat energy which is received at the sea surface now get transmitted towards the bottom, and with the gradual increase in the depth, there is gradual decrease of the amount of heat energy, and that is why the temperature get decreased. Got it? Okay. Now the second line, the profile shows a boundary region between the surface water of the ocean and the deeper layers. When we see this profile, the temperature depth profile, so one thing which is very important here, that a boundary region is found there. What is that boundary? So the boundary regions show that the boundary usually begins around 100 to 400 meters below the sea surface and extends several hundred meters downward. When we talk about such kind of boundary, actually these boundaries in the ocean water are demarcated on the basis of rate of decrease of temperature. Now here I would like to clear the thing. Actually, when we see that maximum temperature occurs at the sea surface or at the surface of the ocean, and temperature gradually decreases with the increasing depth. So one can think that whether this temperature decreases towards the bottom of the ocean with a uniform rate, or you can say the rate it getting changed after certain depth. So the second line is true here. When we start going from the sea surface up to the bottom of the ocean water, so there you can find that the temperature decreases, but with different rates up to a different depths. And so that the boundary region, the line, the depth from where the rate of decrease in temperature is getting changed, it is defined as the boundary region. And that boundary region is defined around 100 to 400 meters below the sea level, below the sea surface, you can say. The same thing. Okay. So in that way you can say that when we discuss about vertical distribution of temperature, here temperature get decreased with different rates, By the help of a diagram, I would like to show you that how temperature get decreased with different rates, right? Here you can see, 1 minute. Okay. See here in this diagram, we can see the temperature depth profile, or we can see the rate of decrease of temperature. A rate of decrease of temperature, you can assess the things. Okay. Now see here. In this diagram, the upper line is showing the temperature, the horizontal line is showing temperature, and temperature gradually increases towards the right. From the left to the right, the temperature is increasing. Increasing temperature, it is written here. Increasing temperature, it is written here. And it is given in degrees Celsius, right? It is given in degrees Celsius. I have written here. And you can see the temperature, the value of temperature has been given as 0 degree, then 4 degree, then 6 degree, it is 12 degree, it is 16 degree, it is 20 degrees, and it is 24 degrees Celsius, right? The temperature, the value of temperature has been given in degrees Celsius, right? Then the vertical line is also given here. This vertical line is showing the depth from the sea surface up to the bottom of the ocean, right? Here the final depth is defined up to 4500 meters. See, it is the average depth taken for all the oceans, average depth taken for all the oceans, because for all the oceans and everywhere in one ocean you can't find the same depth. Got it? So we have to concern with the average depth value. So average depth has been taken up to 4500 meters, 4500 meters, right? Okay. At the sea surface, the depth is 0. Obviously, after that, we have the depth of 500 meters, then 1000 meters, then 1500 meters, 2000 meters, 2500 meters, 3000 meters, 3500 meters, 4000 meters, and 4500 meters. In this way, the depth has been given. Okay. Now see here, when we draw this diagram, here you can see in the first section, it is the first part, and a line or a limitation is defined here, and that is around you can say around 300 meters. Around 300 meters a line is given here. Above this line, if you say from the sea surface up to the depth of 300 meters, you can see that there is a decreasing trend of temperature, but the temperature is not decreasing with a rapid rate. It is a very slow rate of decrease in temperature. How you come to know? Because if you take this temperature around 23 degrees Celsius, so from 23 degrees Celsius, it comes to 21 degrees Celsius. That means in the depth of 300 meters, there is only a 2-degree difference in the temperature from the sea surface. Got it? So if it is so, if there is only 2 degrees Celsius of temperature get decreased at the depth of 300 meters, you can imagine that what would be the rate of decrease in temperature. It is a very low rate of decrease of temperature. Got it? See why it happens here. Why up to the depth of 300 meters? And you can see also that up to, if we see up to here, you can say that there is almost no change in the temperature of the ocean water. The major change has been started from the depth of 200 meters up to 300 meters. Got it? Why it is so? So if you recall, in the previous session, I told you about the photic zone and aphotic zone. I told you that when there is incidence of solar radiation on the sea surface, solar radiation are not only restricted up to the sea surface, it is able to penetrate the ocean water and go up to a certain depth. This depth is defined on an average up to 200 meters. When the incident solar radiation penetrate through the sea surface and go beneath the sea surface, it provides two things. One thing is what? It basically eliminates the region below the sea surface up to a certain depth. That region got eliminated, and that is why the region has been given the term photic zone. It has been given the term photic zone. But in the photic zone, again one thing happen also. That is what? The incident solar radiation which is able to penetrate the sea surface, it not only provides the heat energy to the sea surface, it also provides some amount of heat energy to the ocean water below the sea surface. And that is why the amount of heat which is transmitting from the sea surface, it get compensated by the amount of extra heat energy that is provided by the penetrating solar radiation. And so that you can observe here that nearby up to 200 meters of depth, the temperature is not going to be changed so much. There is very insignificant change in the temperature of the ocean water up to the depth of 200 meters. But after the depth of 200 meters, since the solar radiations are not able to penetrate further, there is only the transmission of stored heat energy which is found up to the depth of 200 meters. Then after only that heat get transmitted further downward. So up to 300 meters it takes place with a slower rate. But what happened then after? So we will discuss it in later. But here the 300 meter up to the depth of 300 meters, you can see a layer of ocean water is defined. See, in the book of NCERT, if you go through the text of NCERT book, there it is written as the first layer. It is written as the first layer, right? But alternatively, in oceanography, this layer has been defined as epilimnion. Epilimnion. Epi means the outermost part. If you remember, we came across the term of epicenter and hypocenter. So epicenter is found at the surface of the earth and hypocenter is found below the surface, right? So epilimnion, it is the first layer which define the characteristics of this first layer is that the decreasing trend of temperature is taking place here with a very slow rate. With a very slower rate you can see here. Then after what happened? So after the depth of 300 meter, you can see that the temperature get decreased. Temperature is getting decreased with a very rapid rate. Now after the depth of 300 meter, you can see if we take the temperature around 21 degrees Celsius, it comes up to around 4 degrees Celsius at the depth of 1000 meters. So in the depth of 700 meters only, the temperature decrease from the 22 degrees Celsius to 4 degrees Celsius. It means almost there is a decrease of 18 degrees Celsius is found here. Got it? So in that way, the major thing is what? That if you define this part where the temperature is decreasing with a very rapid rate, a term is used to define this layer. It is written as thermocline layer. It is defined as thermocline layer, and in your NCERT book, this second layer has been defined as the thermocline layer. What is the characteristics of this layer? So it is written in your NCERT that a rapid rate of decrease in temperature is found here. Decrease in temperature is found here. A rapid rate of decrease in temperature is found here. Got it? It is the second layer that is called as thermocline layer. While rapid rate of decrease in temperature is found because this is the zone in which there is no penetration of the incident solar radiation. Now this whole zone comes under the aphotic zone. And not only this, below this thermocline layer, the zone is also aphotic. But what is important here that If we assess the amount of heat energy which is left here at the depth of 300 meters, now only that amount of heat is getting transmitted towards the bottom. And it approaches the lowest temperature towards the bottom. So up to the temperature of 4 degrees Celsius, it is getting decreased here. It is shown here in this diagram. What happened after that? So after that, you can see that at the depth of 1000 meters, when we see, here we have again the decreasing trend of temperature. See, it is very common for all the layers. The common thing is what? In all the layers, the temperature is decreasing with the increasing depth. That is what it is written earlier. But again here you can see that when temperature is getting decreased here, from the 4 degrees Celsius, it goes up to 2 degrees Celsius. Again, there is decrease of only 2 degrees Celsius of temperature. But within which depth? Within the depth of 1000 meters to 4500 meters or 4500 meters. That means in the depth of 3500 meters, there is only an insignificant change of 2 degrees Celsius of temperature. Here you can measure that what is the rate of temperature per meters of ocean depth. It is very little, very insignificant. And that is why oceanographers and geographers say that actually this is the zone which shows almost uniform kind of temperature in the ocean water. The temperature in this layer is almost uniform. No significant change can be observed here. One thing I must make you clear, that when we see this first layer, in the first layer we saw that the decrease in temperature was taking place with 2 degrees Celsius there. And in this depth again there is only change of 2 degrees Celsius of temperature. But according to the depth of water, you can say, you can decide the rate of decrease in temperature. Since here the depth is more, obviously the rate become very less. And here the depth is only around 300 meters, so you can say the rate is a little more than that of this layer. Oceanographers normally used again a different term, but here in your NCERT book, this third layer is defined with the name of third layer only. It is written there in your NCERT book. But oceanographers used the term hypolimnion. So we have two different layers, the first layer and the third layer, and in between these two there is a layer which is quite different from both the adjacent layers. Why it is so? Because it is the only layer in the ocean water which shows the rapid rate of decrease in temperature. Thermocline, how this term is formed? So you can say this term is formed by using two words. Thermo, that means temperature, and decline. Cline is taken from decline. So the layer in the ocean water where there is a rapid decline in the temperature, that layer has been called as thermocline layer. Got it? So here we have the first layer epilimnion, the second layer thermocline, and the third layer is hypolimnion. And you can see, you can observe the rate of decrease in temperature, slow rate of decrease in temperature, rapid rate of decrease in temperature, and again insignificant rate of decrease in temperature. Why I have used this insignificant term? Because here you can say that there is a change of only 2 degrees Celsius of temperature, but for a greater depth, that is why the change in temperature is very insignificant here. Got it? Okay. So here we have seen that how temperature is getting changed with the increasing depth. But one more thing we have to observe here. In the start of the class, I told you that the maximum amount of heat energy is received on the sea surface. That after that, the amount of heat energy is transmitted towards the bottom. It is very clear. But again, you have to observe that when we go from the equator towards the poles, the amount of heat energy received on the surface also, it is also getting decreased towards the poles. So when this kind of thing is taking place there or at the surface, you can say the received amount of heat energy is transmitted towards the bottom. Wherever the received amount of heat energy is much, there is much transmission of heat energy towards the bottom. If there is a little amount of heat energy received on the surface, you can say the transmission of heat energy towards the bottom is very insignificant. So here we have to recall that chapter where we did the formation of temperature zones on the earth's surface. You all remember, I hope that you all remember that on the earth's surface, there are 3 temperature zones. The first temperature zone is found between the Tropic of Cancer and Tropic of Capricorn, right? It is the Tropic of Cancer. I write here 23.5 degrees north, 23.5 degrees south. It is the Tropic of Capricorn. This is the zone on the earth's surface which receives maximum amount of insolation, because for this region the solar radiations are more or less straight, or you can say perpendicular. And wherever the solar radiations are perpendicular, you can say that region receives more and more heat from the radiation. Got it? One can also observe that since this region comes between the latitudes of 23.5 degree north and 23.5 degrees south, this region can also be said as the low latitudinal region. Then after, between the Tropic of Cancer and Arctic Circle that comes at 66.5 degree north latitude, and the Antarctic Circle that comes at 66.5 degrees southern latitude. Here, in between these two latitudes, the change in the temperature condition takes place with the change in season. Since this zone comes in the middle of the polar region and the tropical region, so this region can be said as mid-latitudinal region. This region has been said as mid-latitudinal region. And then beyond 66.5 degree north latitude and 66.5 degree south latitude, we can find the frigid zone. This zone is the frigid zone. So we have the tropical zone, the temperate zone, and the frigid zone. If you remember, if you are not able to recall this, go in the chapter of temperature and heat budget we did there. Okay. Now see here, when we talk about these 3 zones, here it is written in your book, and you can also observe the same thing, that if it is the low latitudinal region which receives the maximum amount of insolation, the maximum amount of heat energy, so due to this, the transmission of heat energy is taking place with very significant manner, in a very significant manner. And so that it is said that for the low latitudinal region, these 3 layers of temperature distribution are found in the tropical zone throughout the year. Remember what I am saying here, that in the low latitudinal region, the three-layer system of distribution of temperature is found throughout the year. Why throughout the year? I told you that it is the only zone on the Earth's surface which gets maximum amount of insolation, maximum amount of heat energy throughout the year. So that amount of heat energy is getting transmitted towards the bottom, and this takes place throughout the year, so that this three-layer system of distribution of temperature is found there. But for the middle latitude, again you can observe that this three-layer system of distribution of temperature is found, but there is a condition. What is that condition? The condition is saying that in the middle latitude, this three-layer system of distribution of temperature is formed only in their respective summers, not throughout the year. For the low latitudinal region, it is the low latitudinal region. So for the low latitudinal region, the three-layer system of distribution of temperature is formed throughout the year. But for the mid latitude, it is the mid latitudinal region, or you can say the temperate region, mid latitudes. I am writing here mid latitude. So in the mid latitudinal region, this three-layer system of decrease in temperature is formed. It is formed only in their summers. How you define their summers? So it is said that when there is northward apparent movement of the straight rays of solar radiation, the temperature is going to increase in the mid latitudinal region also. It is the equator if you consider. So the solar radiations are straight at the equator on 21st of March, all you know. After 21st of March, the straight solar radiations are moving towards the Tropic of Cancer. The regions for which the solar radiations become straight, that region gets maximum amount of insolation. But what happens to the adjacent areas? So you can say, since the adjacent areas are not exactly receiving the straight rays of sun, but for those regions also the solar radiations are not so slant, the solar radiations are not so oblique. For those regions they are nearby straight or a little oblique or a little slant. That is why they are also getting some amount of heat energy, some more amount of heat energy than that condition when for those regions the solar radiations are not so slant. Got it? So when the straight rays of solar radiation are moving towards the Tropic of Cancer, and as you know, the straight rays of solar radiation only reach up to Tropic of Cancer, and then after it again reverts towards the equator. Okay, so when this thing is happened, that means the solar radiations are going towards the Tropic of Cancer, the temperature is getting increased in the mid latitudinal regions too. In the northern mid latitudinal region, I am talking about the movement of solar radiation after 21st of March. So after 21st of March, since the solar radiations are moving towards the Tropic of Cancer, the temperature in the mid latitudinal region is also getting increased. When anywhere on the Earth's surface the temperature is getting increased, you can say it is the summer season for that region. Now all we observe, since we are living in the northern hemisphere, and after 21st of March the straight rays of sun is moving towards the Tropic of Cancer. On 21st of June it exactly reaches it exactly reaches to the Tropic of Cancer. So everywhere in the northern hemisphere, we all observe the increasing trend of temperature, and that is why we say that summer comes. Summer has come there, right? So if we are talking about the northern latitude, and it happens in the northern latitude after 21st of March that the temperature is getting increased, so you can say the summer is coming there. And so that you can say here more amount of heat energy is received on the ocean surface, which is getting transmitted towards the bottom. And so that in the middle latitude of northern hemisphere, this 3-layer system of distribution of temperature is formed in its summer. The same thing happened in the southern middle latitudinal region after 23rd of September, because after 23rd of September, the straight rays of sun move towards the Tropic of Capricorn. And so that there is a start of summers in the southern mid latitudinal region, and so that the 3-layer system of distribution of temperature is formed there in the southern hemisphere. So what you should remember from here, that in the tropical zone, in the low latitudinal region, the 3-layer system of distribution of temperature is formed throughout the year. In the mid latitudes, the 3-layer system of decrease of temperature is formed only in their summers. And what happens to the high latitudinal region? What happens to these frigid zone, these two zones? So I hope that you remember for the frigid zone that it is the zone for which the solar radiation, the incident solar radiations are always oblique. Too much oblique. The angle is very small. Got it? So that this region is not getting enough amount of heat energy, and so that the temperature at the surface of the ocean water is not enough to get transmitted towards the bottom. And so that geographers observe that in the high latitudinal region or in the frigid zone, there is no occurrence of 3-layer system of decrease in temperature at any point of time in the year. No. Why? Because no enough heat energy is received at the ocean surface in the frigid zone. So what kind of trend of temperature is seen in the frigid zone? Geographers say that actually the frigid zone or the high latitudinal regions are those where there is only one layer of temperature for whole of the ocean water from the sea surface up to its bottom. Only one layer. Because if a meager amount of heat energy is received at the surface, now only this amount of heat energy is transmitted towards the bottom. So one can observe, one can feel that with what rate the temperature is getting decreased towards the bottom. It is very insignificant. It is almost you can say very small. And so that only one layer of temperature is found from the surface towards the bottom. That is what you have to remember. So in the vertical distribution of temperature, what you have to remember, first of all, the 3-layer system. The first layer, very slow rate of decrease of temperature. The thermocline layer, rapid rate of decrease of temperature. The third layer, insignificant rate of decrease of temperature. Among these three layers, the third layer or the hypolimnion layer is showing almost constant temperature or uniform temperature in whole of the water. Right? So first thing, the 3-layer system. Second thing, if we consider or if we divide the whole of the Earth into low latitudinal region and middle latitudinal region and high latitudinal region. So for which region these three layer system of distribution of temperature are formed? For low latitudes, these are formed throughout the year. For middle latitudes, these are formed in their respective summers. And for frigid zone, these are not formed. In the frigid zone, there is only one layer of temperature from the surface towards the bottom. This is the thing you must consider here. Got it? Okay. Then after, what you have to remember, before that, before we move towards the horizontal distribution of temperature, I would like to show you the remaining text here, right? See here, this boundary region from where there is a rapid decrease of temperature is called as thermocline. I told you earlier, right? Then after, about 90% of the total volume of water is found below the thermocline in the deep ocean. In this zone, temperatures approach 0 degrees Celsius. I told you, I have shown you that this is the third layer, and if we compare that, if the whole depth is almost 4,500 meters from the sea surface, about 3,500 meters of depth comes under the third layer. And so that for whole of the ocean water, about 90% of the ocean water is seen with almost insignificant kind of temperature, and the temperature is approaching up to 0 degrees Celsius, right? That is what it is written here. Okay. Now see here, the temperature structure of oceans over middle and low latitude can be described as a three-layer system from surface to the bottom. I told you, if we want to define wherever on the Earth surface the three-layer system of distribution of temperature is found, it is the low latitude and mid latitude. But further it is written that the first layer represents the top layer of the warm oceanic water, and it is about 500 meters thick with temperatures ranging between 20 degrees Celsius and 25 degrees Celsius. With the diagram, if you observe, so here in the first layer you can find that the temperature is found between 25 degrees Celsius and 20 degrees Celsius, right? Ocean to ocean it gets changed. What is taken here is the average value, right? So if the first layer is formed anywhere, it is followed by the second and third layer. That is the meaning of that line. So if this line is saying that the first layer represents the top layer of the warm oceanic water, and it is about 500 meters thick with temperatures ranging between 20 degrees Celsius and 25 degrees Celsius. Again, read further. This layer within the tropical region is present throughout the year, but in mid latitude it develops only during summer. What does it mean? It means that when the first layer of the temperature in ocean water is formed, then after it is obviously followed by the second and the third layer. So here the author wanted to say that after the formation of the first layer, it is followed by the second and the third layer, and so that if we observe the formation of first layer, we must be conscious that the three-layer system of distribution of temperature is definitely going to be formed. So if it is saying that in low latitudes the first layer is formed throughout the year, that means definitely the three-layer system of distribution of temperature is found in the low latitudes throughout the year. In the mid latitude, if it is written that it is formed, it develops only during summer, that means only during summer the three-layer system of distribution of temperature is found in the respective mid latitudes. Because for the mid latitudes the time period of the summer season is different. Got it? Okay. The second layer called the thermocline layer lies below the first layer and is characterized by the rapid decrease in temperature with increasing depth. The thermocline is 500 meters to 1000 meters thick. I told you about this earlier. The third layer is very cold and extends up to the deep ocean floor. It extends up to the deep ocean floor. Here what you have to remember that the third layer is not having much amount of heat energy, as you have seen there that the temperature of water is around 4 degrees Celsius or 3 degrees Celsius or 2 degrees Celsius. Obviously the water would be colder. And so that the third layer is called as the cold layer of the ocean water, where there is very insignificant change in temperature, or you can say it is the layer in the ocean water which is having almost uniform kind of temperature, and it is the cold layer. It extends up to the deep ocean floor. In the Arctic and Antarctic circle, the surface water temperatures are close to 0 degrees Celsius, and so the temperature change with the depth is very slight. Here only one layer of water, cold water exists, which extends from the surface to the deep ocean floor. I was telling you that in the frigid zone or in the high latitudinal region, there is only one layer of temperature from the sea surface up to its bottom. And why it is so? Because very insignificant amount of heat energy is received on the sea surface. Got it? Okay. Now read further. The average temperature of the surface water of the oceans is about 27 degrees Celsius, and it gradually decreases from the equator towards the poles. Okay. So now it is asking about, or it is telling you about the horizontal distribution of temperature from here. Okay. From these points, now we will move towards the horizontal distribution of temperature. So what is important here? It is saying that the average temperature of the surface water is taken about 27 degrees Celsius. It is for considering the whole of the oceans: Pacific, Atlantic, Indian Ocean, then Arctic Ocean and Southern Ocean. All the oceans are taken together, and their average temperature is defined around 27 degrees Celsius. Where? Nearby the equator. And it is said that it gradually decreases from the equator towards the poles. At the surface, the temperature is found 27 degrees Celsius nearby the equator, and then it gradually decreases from the equator towards the poles. That is the meaning of this line. Got it? Okay. Now I am taking here another diagram which is showing the horizontal distribution of temperature. So here you have to consider this diagram. Here you have to consider this diagram. Okay. 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 See here. Here I would like to show you first of all the equator. Say it is 0 degree latitude or the equator. This red dotted line is showing the equator here. Then after, you must consider that it is the northern hemisphere, it is the southern hemisphere. What would be the trend of temperature? So everywhere if you find these lines which are drawn here, these are the isotherms. Isotherms means the imaginary line which joins the different places of equal temperature. Got it? So these are the isotherms. And here what you have to remember, that the decreasing trend of temperature which is taken with certain values nearby the equator, it is taken as 30 degrees Celsius, then it is 25 degrees Celsius, then 20 degrees Celsius, then 15 degrees Celsius, 10 degrees Celsius, 5 degrees Celsius, and 0 degrees Celsius. So you can observe that the trend of isotherm is here. What should be the trend of isotherms? The trend of isotherm is found like this. Okay. For the southern hemisphere, you can observe the same thing, the decreasing trend. It is again 25 degrees Celsius, then 20 degrees Celsius, then 15 degrees Celsius, then 10 degrees Celsius. It is 10 degrees Celsius, then 5 degrees Celsius. 5 degrees Celsius is written here, and then 0 degrees Celsius. It is 0 degrees Celsius. And if you draw the isotherms are drawn like this. Now, what important thing you can observe here? First of all, the regions, the zones which have been shown here in the middle is the region of Pacific Ocean, right? You can recognize the land parts, recognize the continental part. It is North America, it is South America, it is Australia with New Zealand, it is Asia and Europe, it is Africa, right? So between Asia and North American region, it is Pacific Ocean. Between North America and you can say the European region, it is the Atlantic Ocean. Between South America and Africa, it is Atlantic Ocean. Africa is here. And below the Asian region and towards the east of Africa and west of Australia, we have the Indian Ocean. So if we observe the trend of decreasing temperature, because as it is written very abstractly, in a very abstract manner, it is written that the temperature decreases from the equator towards poles. Temperature decreases from the equator towards poles, right? It is written there. So the same trend you can observe on this diagram. But what is different here? The difference you can find in the drawing of these isotherms. If you observe that in the northern hemisphere, what would be the distance between two subsequent isotherms, and in the southern hemisphere, if you observe, so particularly you can observe that wherever there is water, ocean water, which is in more contact of the land surface, the temperature is not going to be decreased with a regular manner. Here in the northern hemisphere, which is also called as continental hemisphere, where the proportion of continent is much, so you can observe that here, since the ocean water is in much contact with the land part, with the continental part, the decreasing trend of temperature is not as similar as we can observe in the southern hemisphere. In the southern hemisphere, you can see a regular gap between the isotherms. And in which region you can find it? The region wherever the ocean water is not in much contact with the land part. Wherever it is in contact of the land part, you can observe that here the difference between the isotherm is not much. And this thing is also observed in the northern hemisphere. But one thing which is common for northern hemisphere and southern hemisphere is the decreasing trend from the equator towards the poles. It is the common. Got it? So what I would like to tell you here, that actually we can't find the maximum temperature. We can't find the maximum temperature at the equator or nearby the equator. Why it is so? Because I told you earlier that there is occurrence of rainfall on daily basis in this region. And so that the water which gets heated in the early period of the daytime, After the occurrence of the rainfall, the temperature decreases very sharply, and so that for whole of the day, the average temperature, if you take, the average temperature becomes a little lesser. Got it? So in that way, highest temperature is not found nearby the equator. It is found a little towards the northern side. One thing you must consider here in the horizontal distribution. We came across with two things. First thing is, from the equator towards the poles, temperature gradually decreases. First thing. Second thing, highest temperature is not found at the equator or a little nearby the equator, say from 5 degree north to 5 degrees south latitude. Why it is so? Due to the occurrence of rainfall on daily basis. It is the reason. Now the third thing you must observe here, that if I am saying that the northern hemisphere is continental hemisphere and southern hemisphere is oceanic hemisphere, so there is a term which is used oftenly in geography is unequal distribution of land and water on the globe, unequal distribution of land and water on the earth. Due to this unequal distribution of land and water on the earth, if we want to define the average temperature of the ocean water on the surface, average temperature on the of the ocean water in the northern hemisphere and southern hemisphere respectively, so the temperature of the ocean water in the northern hemisphere is a little more than that of the southern hemisphere. That is important. Around 19 degrees Celsius of average temperature is found in the northern hemisphere ocean water, and it is around 16 degrees Celsius is found in the southern hemisphere ocean water of the southern hemisphere. What is the reason behind that? So the reason is only one, that is unequal distribution of land and water. Got it? So these three things you must consider here for the horizontal distribution of temperature. Right? Now come to the text. Average temperature we came across. Now see here. The rate of decrease of temperature with increasing latitude is generally 0.5 degrees Celsius per latitude. It is a factual thing. It is a factual thing you must consider here. 0.5 degrees Celsius per latitude. Right? Then after, since it is the decreasing trend from the equator towards the poles, see here, the average temperature is around 22 degrees Celsius at 20 degree latitude, 14 degrees Celsius at 40 degree latitude, and 0 degrees Celsius near the poles. These are the facts given in your NCERT book. I have taken from here directly. Nothing to be hidden. The oceans in the northern hemisphere record relatively higher temperature than in the southern hemisphere. I told you. The highest temperature is not recorded at the equator but slightly towards north of it. Why it is so? Because there is much part of continent in the northern hemisphere. Expanse of ocean water in the southern hemisphere. The average annual temperature for the northern and southern hemispheres are around 19 degrees Celsius and 16 degrees Celsius respectively. I was telling this variation is due to unequal distribution of land and water in the northern and southern hemisphere. That is what I was telling you further. Got it? Then it is a well-known fact that maximum temperature of the oceans is always at their surfaces because they directly receive the heat from the sun, and the heat is transmitted to the lower sections of the oceans through the process of convection. I was telling you earlier that if we talk about the transmission of heat from the surface, transmission of heat from the surface of the ocean water towards its bottom, it takes place by the process of convection. It takes place by the process of convection. Got it? And final thing you can see here, it results into decrease of temperature with the increasing depth, but the rate of decrease is not uniform throughout. I told you that Since the rate of decrease of temperature is different from the surface up to the bottom, that is why we have defined the 3-layer system of distribution of temperature. Okay, and finally the temperature falls very rapidly up to a depth of 200 meters, and thereafter the rate of decrease of temperature is slowed down, right? Okay, so what is important here? What is important here, that the distribution of temperature in the ocean water can be seen in two ways: horizontal distribution of temperature, vertical distribution of temperature. But the points are very, you can say, some in number, and those points I repeatedly told you in whole of the lecture, that what you should remember in the vertical distribution, what you should remember in the horizontal distribution, right? Okay, so this is what we have to know about the distribution of temperature of the ocean water. Here I must tell you that if you have any query regarding this lecture, do write in the comment box and write your question there, write your queries there. I will definitely answer you regarding the queries, regarding the questions, right? And obviously, if you have any suggestion, if you want to suggest me that on which topic I have to give you, or I have to record the lecture, obviously you can suggest that topic too. Thank you very much for being with me in this session. Meet me in the next session. Thank you.